Chapter 27, Problem 66. This problem involves two discharging capacitors. Let's remind ourselves about charging and discharging capacitors. I'll build this RC circuit in FET, connect a voltage sensor across my capacitor, close the switch to the battery, and watch how my capacitor charges. You can see I get this logarithmic growth curve, and my capacitor charge gradually approaches the same charge as the battery. Now I'm going to disconnect the battery and discharge the capacitor. Now you see the exponential decay of the capacitor charge. The problem states the ratio of the initial charges on the two capacitors is Q2 over Q1 equals 1.64. I'm going to change the notation a little bit and just refer to this as Q2 initial over Q1 initial equals 1.64. Your green sheets in the YouTube video spent a lot of time focused on charging and discharging capacitors. Here's the charge across capacitor 1 as it discharges. Here's the charge across capacitor 2 as it discharges. I'm going to go back to step 1 and express the initial charge on capacitor 2 in terms of charge 1. The initial charge on my capacitor 2 is equal to 1.64 the initial charge across capacitor 1. That again was given. At some time t, the charge across capacitor 1 is equal to the charge across capacitor 2. Okay, step 5. I'm going to write down the charge across capacitor 1 as a function of time. This again was provided in the green sheets in the YouTube video. Capacitor C1 and capacitor C2 are discharging at different rates, but at some point in time they happen to have the same charge. I'm going to rewrite step 5 and this time replace Q2 with the equivalence I got in step number 1. Okay, at this point I'm pretty much done. I can cancel similar terms on both sides of equation 6. I know the value of R1, C1, R2, and C2, so I'll just solve for t and be finished.